It's here.
All right, great. Um, so, hello everyone. Who am I? I'm Sam. I'm a data and cloud architect working as a consultant in Belgium. I live in a small town called Hessenberg. I've been working in data for about 5 years now, and in software architecture, cloud, software engineering, these kinds of things, always in the Microsoft stack for the last 10 years. My main focuses are today Microsoft Fabric, Microsoft Azure, the modern data stack, open source software, and I'm also a Microsoft Data Platform MVP. What we'll talk about today is data mesh, like the title says. Also a bit about Medallion architecture, and then we'll see how those two come together and how we can implement that in Fabric in a very pragmatic, practical way. Um, to do so, we'll see a bit what the concepts are of workspaces and capacities. And we'll talk a bit more about capacities, how you can design them for scalability within the bigger frame of data mesh and Medallion. And then we'll also see how you can use domains in Fabric and a few ideas to manage access control. So let's get started with data mesh. Data mesh is a concept from 2019 introduced by Zhamak Dehghani, who worked at ThoughtWorks. ThoughtWorks is a company founded by Martin Fowler, also someone quite famous in the world of software engineering. And Martin Fowler came up with kind of innovative ideas. And we also saw something similar there with data mesh by Zhamak Dehghani. The goal of data mesh, of what she wanted to accomplish there, is overcoming the challenges of the monolithic data lake. So she wrote 2 blog posts about it, and I'll share my slides at the end, and then you can find links to the blog posts. We see the monolithic data mesh as a bit of a problem. Why? Well, here's a picture of it. So we have to the left operational data plane. So this is the applications where all the databases connected to operational things live. So for example, if you have a web shop, then your web shop's database is connected there. And at some point, you'll want to extract data from your operational data applications into the data plane, into the data lake. So to do so, you have lots of ETL pipelines, and they do lots of different things. From their data goes into your data lake, and there you still transform the data to a different version, so that you can, in your data warehouse in the end, present the data to, for example, data analysts or data scientists. Now, what you see on the picture are different colors. The data components being blue, and then machine learning in this part purple. And then we see also a bit of red, which are all the data transformations happening, the data loading and so on as well. And then the green is the data analysts and data scientists. Now, what is typical for most organizations is that the people who actually know most about the data are the ones in green. So the people who are looking to build reports, who need insights from the data, who work closely with business people, maybe they are even business people themselves, and not purely IT staff. They actually know the data best because they know what a certain term means in the company. And why is that important? Well, for example, if you go somewhere to your customer as a consultant and you ask them, what is the definition of a customer to you? You might find different answers. For example, someone might say, okay, to me, a customer is someone who has purchased at least one item from us. Someone else might say a customer is someone who is maybe already a lead and who is looking to purchase something, and maybe they've already done a few sales conversations, but they haven't maybe purchased anything yet. And as you see, that something simple like customers can already be different depending on how who you ask. And this is quite common, but in your organization, there might be very specific terms, which then also might have very specific meanings. So the problem is the people in red doing all transformation work and actually extracting data and working with those columns and then transforming them. they always don't know that much about the data. They're very experienced. They know tools like Spark and SQL Server and data warehousing tools and so on. They know them quite well. They're really the experts in this matter, but they're not experts in the data itself. And this is a bit what we want to solve with the data mesh. There are 4 principles in the data mesh, and we'll go through each of them. The first one, also the most important one, is that we'll work with domain-oriented decentralized data ownership. Now, what does that mean? It's a complex term, maybe, but it actually is important to look at every word in there. Domain-oriented means that we're going to look at different domains of data. A domain of data in your organization is something that is containing data that belongs together in a very sensible way. All data that you typically would categorize under one category. For example, if you're talking about a company that provides air travel, you could say everything related to the booking system, like purchasing tickets, maybe refunds in the end as well, the payments of those tickets, these kinds of things. They're all bookings related. And then managing the actual airplanes, the maybe ground material they need, maybe cars they need to drive from place A to B. It can be logistics, and then the flights themselves that they operate can be another category, because they also have lots of other categories than just data about flight from point A to point B, because there's also the time you need to taxi and which runways you take and so on. So the domains are very structured for a company. What's often a mistake there, if you're looking at what are the domains in my company, just look at the teams and departments you might have. That's not the same thing, because the domain of your company, domains you have in your company might change throughout the lifetime of an organization, but they might change very slowly. Because, for example, the company providing flights is not going to tomorrow have different domains than today. Suddenly, maybe, I don't know, in 30 years' time, we'll have flights to Mars, and they'll also have to add space travel there. But as you see, it's not something that happens overnight. While teams can change overnight, maybe the teams handling payments might be different from the teams handling payments today. So you see a bit, domains are a very important concept. And then what we're going to do is let the specific domains own the data, provide data ownership to those domains. So usually a domain has one or more teams working on that domain. One team might also cover multiple domains. What you want is that the teams working on that domain, they own the data. So there's decentralized ownership. It's not central anymore. Before, your data team, the central data team, was the owner of all data. Today, the responsibility about the data lies within the decentralized domain teams. Then we'll also see data product thinking coming up there. Data product thinking means that our data products are something new, a new concept, and we start to think of our data as products. So what does that mean? We're going to build something that serves a certain purpose that someone wants to consume. We're going to build something maybe for another team, or maybe for a public audience or something like that. But it's not just a table anymore somewhere. It's a product that you're going to treat as such. Like if you sell something, you want to be the product as good as possible so that your customers will buy it. And here as well, think of your data as something that you'll have to sell to someone else. It has to be user-centric. You build your data for someone else, not for yourself. Otherwise, what's the purpose? Might be in some cases domains need insights from themselves, of course, but then also think of yourself as both the customer in this case, as well as the one who's supplying it. What you'll see with data product thinking is that you'll actually get 2 new kinds of relationships. Well, one relationship, but in 2 ways: the data producer and the data consumer. So you have data producers that produce the data consumers that consume the data, and we're going to let the data producers build the data for the data consumers. Means that your product has to have certain levels of quality, that we might guarantee a certain amount of freshness of data, like with SLAs and these kinds of things. So it's really a different way of thinking. And also important that our data product is more than just a final table or a final view or data set you're going to deliver is actually like the entire piece of code and the whole process that comes with it. A data product might also be more than just a table. A data product can also be a report, maybe a machine learning model. Um, those are all data products, and then all the data pipelines that you need to get your data from the source into the final data product also become part of this data product. And then we'll also introduce a principle of self-service analytics. This means that once your data products are there, we have these decentralized domains. They also need to be consumed at one point, and we'll have to make this as much self-service as possible. It doesn't make sense that all of your requests go to a central team, and the central team has to do everything. They get swamped in the amount of work they have. So try to make it possible for the organization, for the data-savvy users, to consume the data without external support. What you need for that, a good data platform. Today you can also hear the term data fabric quite a lot. So something central that holds all of your data products, which is not really built for one data product, but really more generic, and where everyone can discover the data products available and then consume them as well. Your goal is to make them as much accessible and approachable as possible. And then we'll also have to work with federated governance. So once you have this decentralized platform that you're using with data products, it doesn't make sense if they would all work in a different way. So with federated governance, we want to introduce certain rules and guidelines, restrictions we want to put in place so that all data products behave in a similar way. Data product can have different data, of course, but it doesn't make sense if, for example, one team is working with Power BI, another team is working with Tableau, one team is working with Snowflake, and one with Databricks. It becomes very hard to consume those data products. And also the way you name columns and so on. So federated governance is a set of rules and guidelines we do to have good interoperability and standardization across our data platform. So that's important. So those four principles should guide us along the way of building a data mesh. And what's important to take away here for me is that those are four principles. And like with everything in IT, you don't have to apply them to the extreme in 100% way, but I would see them more as guiding principles to make informed decisions on how you structure and architecture a data platform. So these are the links if you want to read more about data mesh. You have the two blog posts here from Zamak Degani. There's also a book that she wrote afterwards because the blog posts themselves became quite popular, but people wanted more content about and go a bit more in depth into this matter. So you can download the book for free as a PDF, thanks to Starburst, another data platform. If you go to this link and then leave your details, they'll send you the PDF. I thought it was just useful to mention that. Then also very useful is the Microsoft Cloud Adoption Framework. If you're working on these certification levels, Azure Solution Architect Expert, something like that, you'll have come across the Cloud Adoption Framework. It's a framework to help companies adopt the cloud, and Microsoft has written a lot of documentation about this matter, specifically about data mesh and so on. So with this link, you'll get right directed to the entry point for that piece of documentation. Then the medallion layers. These are also a popular concept today. What's important there to understand is this is a concept used by Databricks, also early 2020, 2021, something like that. And Databricks introduced it, of course, with the intention to sell their own products. For me as a data consultant working in data now for about 5 years, we already knew these concepts before Databricks introduced them, honestly. So I'll also provide some alternative names there. So the medallion architecture consists of 3 layers, and the first one is the bronze layer. That's also why it's called Medallion, because they're the typical 3 medallions you receive at the end of a race or something. Before, I think Medallion, a lot of people called this the raw layer, sometimes also the landing layer, the landing zone. This is where your data is going to be stored in its original form without transformations or quality checks. So if you have data coming in from a SQL database, store it in, for example, a Parquet file, and don't apply any transformations on it. So that in the end, you'll have the original form of the data, the same column names, the same data types, and so on. If you get data in CSV format directly, just store the CSV file as is. Don't do anything with it. That's a bit the goal of the raw and bonds layer. Literally just load and don't do anything with it. Why? Because later on we'll see the other layers have their own purpose to actually do something with this data. And then if you still have the original form of data, you can always reprocess it if needed. This is really for the modern day and age where we have storage which is quite cheap. Reprocessing data is expensive sometimes, but storing data long term is quite cheap. So it doesn't make sense to not take advantage of this. You have the cleansed layer, or silver layer. This is we're going to increase the quality a bit more of our data. So we come from no quality at all, basically, or maybe there might be quality, but it's not guaranteed at least. Here we're going to enrich the data, clean, transform the data. You're going to want to remove duplicates. You're going to want to make sure data types are correct. You're going to want to make sure that all values in columns make sense. For example, a date of birth in the year -1000 might be something that you have, but chances are very low that you'll know an actual customer, for example, or an employee in your system who has that date of birth. So these kinds of values, either put default values in them or remove them, so that when you do some aggregations, that you're not influencing aggregations too much. For example, almost not really a fan always of default values, because if you put a default value, then your averages tend to go more towards your default values. You have to make sure that you can exclude them in certain aggregations on your data. Then you have the curated or gold layer. So in the cleanse layer, you see it more as maybe kind of Lego blocks that you have, and then you haven't built anything with it. In the gold layer, you can build certain reports and data sets with it that you can then use to gain insights. So this is the highest level of quality. Here you build the data marts, actually. You do aggregations. You want to make sure that you have the right components to build the reports that you'll need in the end. And the medallion layer has 3 layers, but you can also spread it out more to 5 or to 6 layers and have smaller steps in between. But the goal is actually always the same. You start from the raw data, you go to the most curated version of your data that's ready to be integrated in certain reports, where you have aggregations, pre-aggregated data. So that's the goal of the medallion architecture, and how many layers you split it up with, it's up to you. The bronze, silver, gold is quite an easy way to think of it. So that's maybe a good start. Then the question becomes, how do we bring these concepts together a bit? Because we saw on the one hand now the medallion architecture, where we have all those different layers, and the data in there is structured in certain levels of quality. But you also saw that you have to make sure that our different organizations, our different domains own the data separately in some way. How do you do it? So the answer is, of course, different for every organization. This is an example of what I often see being implemented. But the question is then, which data mesh design principles should be applied at which level? So you have the 2 teams on the screen, the central data team and then one of the domain-oriented teams. Why did I structure it in this way? Well, there are certain elements guiding your decision. There can be historical reasons, there can be the reason for data maturity. The more mature your domain-oriented teams are, the more you can make them responsible for as well. You can have expectations from different departments on how they want to work or not work with the data. There can be plans to either upskill the existing team or upstaff the existing teams. And there can also be tools which really act as enablers. And I think Microsoft Fabric is one of the strong tools there, because at Microsoft Fabric, we really have the right tool in hand to do the shift a bit more to the domain-oriented teams instead of staying with a central team. I think with a SaaS-based solution, this is really key. With PaaS, we also had to be a bit more integrators and technically savvy to be able to work with data platforms. So now we're really at a turning point there. So what I've put here is, so then central data team responsible for connecting new data sources. Data cleansing is a task that everyone should be involved in, as well as data governance, but can also shift a bit more left, both of them. And then data modeling and data quality, for example, those are things I think the domain-oriented team are responsible for, while the central data team does not have the right knowledge to do so. But we'll see more in detail when we go to the Microsoft Fabric implementation of what I exactly mean by that. If you want to start with this, often you work with, let's put everything that we'll need as a data product in a domain-oriented team, and then see how much things that you need to build up to that you'll also have to move to the domain-oriented team, or maybe move back to the central data team. So in Microsoft Fabric, maybe let's see, wait in the meantime, because I can't always see both screens together, if there is any questions or something in the chat. So not yet. All right, so then we continue here. With Microsoft Fabric, bringing this to life, you can do this in multiple different ways. And maybe, the most important thing there is, how do we do the design of the workspaces in Microsoft Fabric? So let's see, you can go the Hello World version. Quite simple, you have one workspace. In this workspace, you use, for example, data pipelines to land your data in the lakehouse. Then you use the lakehouse to transform your data. And then maybe you'll build some views in SQL on top of that, and a semantic model, and then you're done. You have your 3 layers. You have your bronze, you ingest your data, you have silver, because you clean your data, and gold, because you'll build some pre-aggregated data sets. So with that, you're done, and maybe I could end my talk there. But I don't think that's the way to go. We'll see a bit how we can fit them up more, and then why this is important to do so. In the bronze layer, we want to ingest the data. So we have to land the data somewhere, and in Fabric, you can store your data either in a lakehouse or in a warehouse. I would recommend, if in your bronze layer, that you would work with a bronze lakehouse, not with a warehouse, because it's a bit more flexible when it comes to ingesting data. Ingestion by itself is a complex task, and thanks to Fabric, it's become less complex. But it's something where you also don't need too much business knowledge. Like ingesting data about payments or about flights, it's the same thing basically, because the difficulty often lies in how you connect to the kind of source system. The difficulty is, for example, to connect to an SAP source, or maybe to an Oracle database, or maybe to a SQL server. That's where you will make the difference in terms of the knowledge you'll need to ingest the data, not in terms of what the data is about. So to me, data ingestion is something that you can do in the central team with specialized data engineers. I don't need too much business knowledge to do so. So you see here, I've put a single workspace on there with different data sources all going into the same lakehouse, but we'll also see different models. What's important is, for the next kind of slides and so on, we have to understand what is a Fabric shortcut. So if you've worked with Fabric, you are already familiar with the shortcuts. If you're new to Fabric, then the shortcuts will be something that you're interested in, and you think, what is this new thing, and how does it work? So shortcuts is really the cornerstone of building any kind of Fabric architecture. What do? They are virtual or logical links to your existing data. Today, Microsoft supports Delta Lake for everything, but they also announced they will support Apache Iceberg. And your data has to live in, for example, ADLS Gen 2, S3 on Amazon, GCP cloud storage, maybe Fabric's OneLake, so the data lake in Fabric as well. So you can connect to your data where it is sitting today. Microsoft has this concept of one copy. You don't copy the data anymore, because the shortcut will expose your data as is into your lakehouse. So if you have your Delta Lake table somewhere on S3 because you created them with, for example, Redshift or Athena, then you can just connect to those tables right away with a shortcut. You don't have to ingest them, and it will become available as a table in Fabric Lakehouses. If you do an update in your source, immediately is there in your destination lakehouse as well. So this is really useful. If you can just connect the data source without ingesting them, so that's very, very powerful. There are two new features if you enable the lakehouse with schemas in Fabric. You can also use schema shortcuts. So meaning you point to a folder somewhere containing multiple data sets, then you'll automatically pull in all those data sets within that folder. You just give the name to the schema and they'll all appear in your schema in your lakehouse. Very useful. And what I will also recommend is if you create your shortcuts and you don't do schema shortcuts, for example, or maybe for schema shortcuts as well, create them using the Fabric APIs. They've went GA a few months ago, I think now. So don't start creating them manually all the time because you have lots of tables. It's quite easy to do so from notebooks or from anything else that you'll interact with Fabric. So how do you ingest your data? Well, shortcuts are an easy way, but that means that your data is already sitting in the cloud somewhere in Delta Lake or maybe in the future in Iceberg as well. So other ways, of course, you have in Fabric the data factory with copy activity. There's a copy job as well, which is quite easy to work with. It's also something new. I think by far the easiest one to ingest data is database mirroring. If you have a database supported by the database mirroring feature, then you just have to connect them, select the tables. I don't have to deal anymore with CDC kinds of things. Fabric will all do it for you. You can automatically ingest new records. You don't have to worry about it. It's happening all behind the scenes. So that's really powerful and allowing you to spend less time on ingestion because there's not too much value from ingestion by itself, of course. We also have data flow gen 2. You can also use notebooks and Spark jobs to ingest data. OneLake also still supports all the Azure Data Lake storage APIs. You can even just drop files into the OneLake File Explorer, like if it's some kind of OneLake client, OneDrive client before. So here you can do it as well with your data. Just move your Delta Lake datasets into it. And then if you are working with the data warehouse of a lakehouse, you can also use copy into or open rowset to get your data into the data warehouse. So lots of different ways, and as you can see, the different technologies are important here and less the business knowledge. So that's why this is something that belongs a bit more to the central data team. Now, how do you structure this? You have maybe, for example, lots of data sources that all sit in one source system. In that way, it depends a bit on how many schemas you have. So there are different structures you can use to structure the data in Bronze. You might go with one workspace, one lakehouse, and then for each source system, you have maybe one schema. And then it only works, of course, if all your source systems also work with a single schema. So I think maybe another one to look at is a one workspace and maybe one lakehouse per source system. Then you can basically get your databases from the sources in there one-on-one and still work within one workspace in Fabric. If you have different teams working on the ingestion, which might also be possible in larger organizations, then maybe it's easier to work with multiple workspaces. And then in those workspaces, work with one or more lakehouses per source system. So it's a bit of choice you can make, and I think the most teams will go to the middle solution, multiple lakehouses in one workspace, because it's a bit easier to manage, and it's, like I said, usually something done by the central data teams. So those are this is the one where you have multiple workspaces, but yeah, like I said, you can go multiple different ways. Then you go to Silver. In Silver, we want to clean our data. And this is something that I spread out on my first diagram between the central data team and then also the more domain-oriented teams. Why is that? Because cleaning data is lots of different things. So one thing can be non-domain specific. For example, getting your datetimes in the right data type. If you ingest data, often they're ingested as strings, varchars, and you want to get them into a datetime2 type in Fabric. Maybe they have to do some time zone conversions. I don't think your domain-oriented teams always have to deal with this, or maybe fixing from going from strings to integers. Those are very common things that you don't have to maybe worry about to have the right business knowledge. But for example, if you work at finance data, you have to ingest columns containing bank account numbers, like IBAN numbers in Europe. Then these have checksums at the end to verify if the IBAN number is actually a correct IBAN number. These kinds of checks that I can put in place are very specific to the domain. So that's maybe something that you can spread out more to the domain-oriented teams. So maybe this can be also two parts. You have Silver, the central part, and Silver, the domain-oriented part. Yeah, it's just a fun picture here to keep it simple. But of course, you can always extend this up to your likings. Common tools to clean your data are Spark jobs, notebooks. If you do it in SQL, then I think a tool like dbt is very useful. And again, here you get your data from bronze into silver, not by copying the data, but by using shortcuts. Why? Because your data is in one lake, it's in Delta Lake because it's in one lake often. So that means that getting your data from bronze to silver is just a matter of creating a shortcut. There are different workspaces, that's no issue because you can create shortcuts across different workspaces. So really the shortcuts are key to having the different structures separately while still having a single copy of your data. How do you do the layout in silver? Well, that's a bit similar to bronze for most teams. I see other companies choosing for Data Vault. I'm personally not a big fan of Data Vault. You can also go with something called white tables. This is a bit up to you what you want to do there. I think Data Vault might be used if you have lots of different sources and you have to align them in some kind of way. But I think sticking with the bronze layout a bit longer and then just having a cleansed version of it can be one of the easiest approaches. Then we come to the gold layout. So here again we work with shortcuts to bring the data into gold layers. Now in gold, I would really recommend to split it out by domains. So applying the decentralized domain ownership to the max here actually. Why? Because we want to transform the data into usable pre-aggregated data sets. They have to mean something. So who knows what the data means best? So these are the domain-oriented teams. So here, split the data by domain. Even if today is still one team working with the data, you can already start splitting out by domain so that in the future you still have the opportunity to do the team split afterwards. Maybe the organization might grow and then the different domains might get their own teams with data stewards in there. So it's easier from the start if you split them out than if you have to split them out later on if they were in one workspace or one data warehouse. I personally always recommend to do the data modeling in SQL here because SQL is very approachable. Everyone in data knows how to work with SQL, while PySpark can require a bit more learning and requires you to understand how Spark clusters work. So why SQL then? Well, because it's also very easy to work with for most teams. They always know SQL already. So just work with SQL there, let's say. To get the data into a SQL environment, we have to think of data warehouses in Fabric. You have to use lakehouses in between. I call these maybe shortcuts hubs because you basically pull in data from Silver and then you'll link your data using these shortcuts into a lakehouse in Gold. And then in the lakehouse, any lakehouse you have is also available to be queried from any data warehouse because you have in lakehouses in Fabric the SQL Analytics endpoint, and these endpoints expose your data in the T-SQL world where we have also the data warehouses, and they can just query any lakehouse within the same workspace. So that's why I would create these lakehouse shortcuts hubs without actually doing something with the lakehouses themselves. And yeah, that way we built our structure for Gold. I've also put here the core skill that you'll need here is index engineering. It's also something coming up now, a new kind of role coming up to work with both reports, understanding business knowledge, having the right insights, and working with SQL. With Fabric, the technology is not so complex anymore, so I think index engineering is really the right skill you'll need to work with gold workspaces. Then how do you get data from one domain to the other? Because you have these data consumer and producer relationships, and one domain consumes data from another domain sometimes. Well, again, create a shortcut. You can create shortcuts from data warehouses into the lakehouse shortcuts hubs that I call them, to use them in other domains. I think it's also very nice because then you see the relationship a bit more. So here we have the data producers, and then the ones consuming the shortcut are the data consumers. And it's also read-only always a shortcut, so that way we are sure that the one here the team managing domain A owns the data, while domain B consumes the data and they cannot modify the data itself. It's a bit what I said. So, for example, the HR team owns all HR data, and they provide the data to other teams if someone needs, for example, a list of employees somewhere. So the entire platform looks a bit like this. Like I said, you can extend this per layer a bit more, like multiple lake houses in bronze, multiple workspaces in bronze. In silver, split a bit between the first step and the second step of the first one, very generic data cleansing operations, while the second step is a bit more domain focused cleansing operations. And you can also have shortcuts between the different gold layers, but then I think the picture becomes very complex and hard to understand. But in general, we have different workspaces, bronze, silver, and gold. Did I invent this? Well, no, you can also find this in the Microsoft documentation. Microsoft also recommends you to work with these bronze and silver zone as lake houses, in gold as a warehouse, and split everything up in its own fabric workspace. So I didn't invent the wheel, reinvent the wheel there, like they say. This is also a bit the general recommendation. You can also extend this. And what I don't like about Medallion is these names about bronze, silver, gold. But if you do want to extend this, sometimes I see people calling extra layers, for example, platinum or something like that. So why does this happen? Because maybe you have very specific purpose-driven workspaces that you'll need with different teams working on it. Machine learning is something that's often an example there. Or maybe data sharing, if you want to only share a part of your data with the public or something like that, that could also be a good idea. So yeah, platinum then maybe to have specialized workspaces. Here I would see the workspaces in general also a bit more like the resource groups you had on Azure, or maybe project folders in other kinds of environments. So you can still extend this up to your likings, because again, shortcuts can be used to create these data producer and consumer relationships along the way. Then workspaces and capacity. So why would you create separate workspaces? Well, a simple one is you have maybe different configurations per workspace. Maybe you want to configure your bronze workspace to connect to certain private storage accounts. You don't want to have this available in your silver workspace. You can use, for example, the workspace trusted access, the workspace identity for this. This is something you configure on the workspace level. So this is maybe already a good reason to split up by layer over the different in different workspaces. Then access control is also quite easy to do on the workspace level, while other levels are also always a bit more complex. If you want to give someone viewer access on a workspace, quite easy, just assign on the viewer role. I would typically assign AD groups, or now Entra ID groups, to my workspaces, give them certain roles, and then use, for example, Microsoft Privilege Identity Management to manage the access, so the membership into those groups, and then you have a very flexible and secure system to manage access to your data. But then we come to capacity management, which I think is a main reason to split up the workspaces, and why I have my workspaces separated for every layer. So capacities. What is a capacity in Fabric? It's basically what you use to compute something. A capacity is a pool of capacity units. It matches a certain amount of compute power. It then spreads amongst one or more workspaces. Every workspace has to be linked to a capacity. Only one capacity. You can't link multiple capacities to a single workspace. The workspaces in Fabric just contain your logical items, the fabric items like lake houses, warehouses, and so on. But as long as there's no capacity linked to it, there's nothing you can do with these kinds of things. So you always have to assign a capacity. There are some ways you don't have to assign a capacity, which I'll also talk about later. But usually think of it workspace just like container to do something with your container, the capacity, which is actual power, the compute power you'll need. And a capacity, like I said, can be assigned to multiple workspaces. So here you see one assigned to 4, these to have their own capacity, these workspaces. And you have one capacity assigned to 2 workspaces. And a capacity is used for everything which is built in Fabric, so really everything. So even if you use Copilot and you ask it a question, it's also going to consume a bit of your capacity. And a capacity always has a certain amount of capacity units. So for example, an F2 capacity on Fabric has 2 capacity units. And F8 has 8 capacity units. The actual building itself is done in capacity in seconds. So here is CUS, while capacities are with abbreviated CU. And also see the different ways of writing. You have CUS here for capacity in seconds, and then here capacity itself, the plural, is written in a different way. How many capacity in seconds do you have? Well, basically every second, your budget is the amount of capacity units you have. Determines the amount of capacity in seconds. So for example, for the F8 here, we have 8 capacity units, meaning our budget is 8 capacity units seconds per second. Then we come to bursting and smoothing, which is really why Fabric is so powerful, and where even with an F2 capacity, you can even do lots of complex things. How does this work? Well, Fabric is going to bill you in a different way than how it's going to execute your workloads. So a workload is built differently than how it is executed. It's very important to understand. So imagine, only look at the red things on the picture. We have a certain amount of capacity units in our capacity. More capacity units means we can do more with it. We have more power. And at certain points, we'll have a limit there because Microsoft is also not giving you their data centers for free. So there's a limit introduced by your SKU, by the amount of capacity units. The heavy workload might go over this limit by itself if you execute it, and then it can be throttled. Now, Microsoft is not going to throttle you that easily. So what happens? Your workload is really flipped not upside down, but to the side. And your workload, the usage it has in terms of capacity unit seconds, is going to be spread out over 24 hours. So you have a certain amount of capacity in seconds you'll need to do something. You'll not be built for it this second, but over the next 24 hours for most things. So how or why does it work? Well, there are 2 kinds of workloads on Fabric. There's interactive workloads. Basically, this is just Power BI. And everything you do in there spread out over the next 5 to 6 minutes. And background workloads, basically everything else, which is not Power BI, is going to be spread out over the next 24 hours. Most operations are background operations in Fabric. Even running a SQL query, how does Microsoft see this? If you can sort something, walk away from your computer, you come back to it, and you then see the result and you're happy with it, that's a background operation. If you click on something and you're waiting for the thing to actually update, that's an interactive operation. So if you slice and dice in Power BI, that's interactive. If you do something like running a SQL query, maybe there it's okay to wait, so there is a background workload. So that means if we bring this all together, for example, an F4 SKU, 4 capacity units, in the next 10 minutes, we can use the capacity unit seconds that we'll have for the next 10 minutes. So that means we have every second 4 capacity unit seconds. If you do it this times 10 minutes, then you get 2,400 capacity unit seconds. If we look at, for example, an F8, we have 8 capacity units. You want to do something in the background, like running a Spark job or a SQL query. If you add up the amount of capacity unit seconds for the next 24 hours, you'll get to over 500,000. So you can actually consume over 500,000 capacity unit seconds to run your Spark job. not to just run that single Spark job, but to just run all the background jobs in your environment. So it's basically a budget you have, and you can do something which takes a certain amount of capacity in seconds. And the more things you do, the less budget you'll have. But every second, your budget is refilled again with more capacity in seconds. And this is how the billing works, but the actual duration of your workload will always be as soon as possible. Now, there's an impact of the SKUs choice, which is not just the budget. Capacities will also determine the features you have. For example, Copilot or Power BI Premium features are only available on F64 or higher capacities. And also, some features not available in full if you have lower SKUs. For example, Spark jobs in Fabric, you get 2 vCores per capacity units. So if you have an F8, that means that you have 16 virtual cores that you can use in your Spark clusters. And it also means that you will have 4 nodes available, and then you can spread out those 16 cores over 4 nodes or over 2 nodes or over 1 node. That's up to you. But the maximum amount of nodes is also determined there. And there's also a burst factor of 3, meaning that you can do 3 of these workloads at the same time in total. That's what the burst factor does. So capacities say how much capacity in seconds you have, which features you have, and then also for Spark jobs, also how powerful your Spark jobs can be, how fast they run. We also have something else which is determined there. Capacity also has a region. Not every region in Fabric has, for example, availability zones. So if you guarantee a certain SLA, where if a data center goes out, then your data should still be available, then you should look at the availability zones because, for example, where I live, West Europe, the availability zones are not available yet for Fabric, and the closest one I should go to is in Ireland, North Europe. So it also is going to influence certain amount of SLAs. It's also going to determine where you store your data. If you have a workspace in Fabric with a warehouse, and the warehouse is connected to a capacity in West Europe, then your data will be stored in West Europe. So the capacity is determining where your data is going to be stored for that workspace. What might happen while throttling? If you consume more capacity units, capacity in seconds, sorry, than what you had available, because maybe you did lots of different background jobs, and after adding them up, they consume more than, for example, for the F8, almost 700,000 capacity in seconds. What will happen is Fabric will throttle you. So at first, you'll see that in the interactive operation, so Power BI, you'll see 20 seconds delay on everything. It does not impact the ongoing operations, only the new things you do. So if you slice some dice, 20 seconds waiting before you see the result. If there are no capacity in seconds available for the next hour, then everything interactive will be denied. And if you consumed everything for the next 24 hours, then all operations are denied. So throttling might impact you. And as you understand now as well, maybe one user might consume your entire capacity. You can have this risk where a single user runs an intensive query, and this query takes up all the next capacity in seconds available for the next 24 hours, then nothing in the organization in that capacity is going to work. So if you have a report that you want to show your CEO every morning, and it's at the same capacity as our data engineering team is exploring things in a sandbox, that's very dangerous. So always split up the capacities per workload, per team, so that you have separate capacities for that, and then that way you avoid this issue where you can have throttling in the capacity by managing it a bit better. How do you know if that's happening? You use a capacity metrics app. I'm going to detail into it, but it's an application you can install in your Fabric tenants where you can see the amount of capacity in seconds consumed by all the operations you have in your capacity, all the ones running in there. But if you want to split up your workloads over capacities, you have to split up over workspaces. And there we come back to why I split up the different workspaces for the different layers and the different teams and different domains. Because if you want to split up these things, you have to split up the if you want to split up the workloads by capacity, you have to split them up by workspace first. So I think splitting it by workspace is not too complex to do, and then assigning different capacities to it, that's, I think, where you can make an actual difference. Then we also saw access control is a good reason. So there are different ways to do access control, and I think the workspace level is the easiest one, like I said. You have there the different roles. You can also do inside the workspace item sharing, where you can also give, for example, read access to only one data warehouse. These are different ways you can do access control, and I think Microsoft's also still working there on something called one security, which maybe will bring new features or less features, I don't know, into this realm. But for now, workspaces seem to be the easiest level to do the actual access control, and then also have a good overview of that access control. But what if you have lots of workspaces and you want to get an overview of the data you have inside? This is where domains come into play. So domains are logical groupings of workspaces. Domains can also have subdomains. So you can, for now, not do too much with them, but what you want to do here is yeah, group your data assets into these domains so that it becomes clear to which domain something belongs. If you have different workspaces and they all belong to the same domain, you can link them together this way. And then maybe you want to look into data from the finance domain, they go to your OneLake data hub, and then you can see all the workspaces or the data inside the workspaces from the finance domain by filtering on this. These are domains, so they have their role. It might be more in the future. From what I said from Microsoft, this is certainly the case, so that they will move things to the domain level to manage more structurally. Today, this is, I think, the very first step to manage your data in different domains. So quick recap, we had the 4 principles for data mesh. We also had the overview of the architecture that I proposed for Microsoft Fabric. So split your workspaces by the type of workload and the role of the people in your data fabric. Single capacities are very good for trials because they allow you to see a bit how many capacity in seconds you'll need to do a certain operation, but then actually split them up into multiple capacities once you get started with using Fabric. Access control might be complex, so maybe the workspace level is also a good place to do so. And then if you want to easily see an overview of all the data you have in a certain domain, you can bundle them in domains. So I have my 5 golden rules for workspace and capacity design in Fabric. Never mix different layers from the Medallion architecture in a single workspace. Never mix data from different domains in the same gold workspace. A workspace always needs 2 things, a capacity and a domain. Now, of course, if you have, for example, Power BI you want to run somewhere, Power BI Premium, you can also still use a Power BI Premium per user today. So that's also still an option. You don't need capacities on, for example, workspace just used for reporting. This is another example of how you can split up gold into even more workspaces. So you can have one for the data warehouse part and one for the reports. Can also be a good idea. Then do split your workspaces and their link capacities by type of workload. You'll not want to have your reports that you'll use in business linked to, for example, ingestion. So split them up a bit more, and then that way, yeah, you have 4 examples here. We can split them up. You'll also leave room for more future extensibility. There is no known valid limit on the amount of workspaces. Microsoft says, I think, that one Power BI user cannot be a member of more than 1,000 workspaces. But we've seen that people have run scripts and tried to actually make a member of over 5,000 workspaces or 10,000 workspaces, and it still worked. So it's a suggestion to not go over the 1,000 workspace limit, but I think also it's going to have more workspaces with this design in mind, but also not 1,000 unless you have very large organizations. And then maybe Microsoft will also do something special for you, I don't know. So build for future extensibility is a message there. You can find the slides on my website, on my blog. So this is the link. And I also see that there's a question in the chat. So you can also still send me questions afterwards as well. So you can go to my website or my blog, or you can send me an email. How would you suggest one data product loading or updating frequency from end to end? In this case, do consumers have to wait for bronze or silver updates and align accordingly? So the nice thing with Fabric is, thanks to the capacities and the smoothing and bursting in there, that you don't have to wait too much anymore. Like before, if you had, for example, one Spark cluster, have to schedule everything sequentially. Like your intensive loads have to run one by one because the Spark cluster cannot take all of them at the same time. With Fabric, it's not the case anymore because you can just throw all of them at Fabric. It will just smooth out your usage and you don't have to wait sequentially anymore. So you can do those updates as soon as you need them, the ingestion and so on. Um, and then your shortcuts will make sure that if you do the ingestion, then your data is immediately available in Silver as well. So that's something that is also very interesting there. So yeah, I wouldn't really put a strong advice on the frequency. I would make sure that your data is loaded as soon as you need it. And if you take some time into account for the actual transformations, then maybe if you need your data at 6 a.m., maybe start at 5 a.m. or something. That could be an idea. If you need it 2 times a day, then update it 2 times a day. It's up to you. I don't see any other questions coming up in the chat.
So I don't see any questions either. But Sam, this was really interesting, and thank you very much for your presentation.
Yeah, thank you. I see one about the slides, so you can find the slides here on my blog, Debruyn.dev, and then you see there the session of today mentioned, and there the slides are available there.
Just to remove the, yeah, this is a link where you can download it. Session will be also available on our YouTube afterwards, so everybody can rewatch it and went through all the details Sam mentioned as well. So Sam, it was really a pleasure to have you with us with a great topic, and audience, I'm sure they are happy and wish you a nice weekend ahead.
Thank you. Same for you, and thank you everyone for attending. All right. Yeah, have a good rest of the conference as well.